Now we're going to look at a case where the demand during lead time follows normal distribution. Okay, in the previous example we looked at discrete distribution. So now we're going to look at normal distribution. So here is our lead time and the demand during lead time, and this is the average demand during lead time, D times L. Now we're going to look at, okay, when we place an order at this point in time, okay, if the demand is very light, so you may end up with that much amount of inventory when the lead time is over, in which case there is no problem. But if the demand is really high, then you may end up here. Suppose if you don't have that safety stock, you would have run out of inventory at this point. So the additional safety stock allowed you to satisfy customer demand even further, and here we run out of stock. And this is the mean demand. If the demand happens to be the average demand, then you would be right there. When the lead time is over, you would have just completed the average inventory, the average demand as the inventory, and the safety stock will remain. Now this is the probability distribution we are assuming, normal distribution. So how much of that safety stock should we add? Okay. And that is given by this formula. So this is demand during lead time, D times L, plus we add a safety stock where Z comes from the confidence level that we want. In other words, service level, 90% or 95%, 99%. And this comes from the normal distribution table. And sigma sub DLT here is standard deviation of demand during lead time. So the DLT is not D times LT, this just represents demand during lead time. And that demand has different formulas under different conditions, so we'll look at that in just a few minutes. So Z times DLT, that's our safety stock. So add these two and we get our reorder point. So in a normal distribution, so this is D times LT, and this is the amount of safety stock that we want, and that depends upon the stock out probability, which is the opposite of the probability of no stock out, and this is our service level. So this gives us the Z table value and then times the standard deviation for demand during lead time. So we will look at some examples, worked out examples now, and there are some worked out examples in the PowerPoint slide also. I'm not going to go over those, and you can go over those. I will now illustrate the problem from the class problem. So here is an ROP problem when the demand follows normal distribution. So here, kitchen ceiling lamp. The anticipated demand during lead time can be approximated by a normal curve having a mean of 180 units. So here, average demand during lead time so this is the average demand, okay, which is D times L, that is given as 180. So we don't know the value for D, we don't know the value of L, but we know the value of D times L. And standard deviation of demand during the lead time, and that is given by this notation, okay, and that is provided as 40. So you don't have a separate formula for different values of D and LT. We will come to that in a little bit. Now service level is 95%. So now we have to use the normal table. So from normal table, Z is equal to, so now we have to go to normal table in the appendix, and then we need to look for Z value from the edges for 95%. So if you go to 95%, right here, you see that it is so 95% is right in between these two, 1.645. Okay, Z is 1.645. So then ROP is D times L plus Z times sigma sub DLT, and that is equal to 180 plus 1.645 times 40, that's equal to 46, and here this part is our safety stock. Now here we were given the sigma sub DLT as 40, but often you will not have that value given. You will have the demand and sigma sub D for one period is what you will have. So let's look at what the formulas we need.